In the lap of mighty Himalayas, India's dream of having the tallest railway bridge is now a reality. India has successfully broken the record of hosting the tallest railway bridge in the world. Bringing the unjoined banks of Chenab, the Indian Railways flaunts its newly completed flagship project, the Chenab Bridge. While we celebrate 75 years of independence, history has been created in Kashmir. The final span of Chenab Bridge has been launched on the arch at a height of whopping 359 meters from the water surface of Chenab. Standing 35 meters higher than Eiffel Tower, this mighty bridge can resist earthquakes and even bomb blasts. In its 150 years of history, the Indian Railways is building the most difficult railway project the country has ever seen. Building a 272 kilometers rail line through the extreme terrain of Kashmir is no joke. Linking Udhampur with Baramulla through bridges and tunnels, this railway line has a high strategic importance for India's defense against the foreign powers. Chenab Bridge, being a part of this project, will lift Indian trains at a height of 359 meters. Our very own LHB trains will give you a feeling of air travel, as the trains will cruise through clouds. Kashmir, the crown of India, is now hosting one of the most precious jewels that we have, leaving our neighbor China and other so-called superpowers behind. On this auspicious day of India's independence, celebrate Azadi with the revolutionized Indian Railways.
The Udhampur-Srinagar Baramulla Rail Link USBRL project is one of independent India's most challenging and important infrastructure projects. One of the most challenging parts of this project is a single arch bridge over river Chenab coming up between Kauri and Bakkal in Riyasi district. On completion, it will be the tallest railway bridge in the world. Standing at 359 meters, it will be 35 meters higher than the Eiffel Tower. But this bridge is a world-beating project, not just for its height. Its design and construction are very special and unlike anything anywhere in the world. It is the first bridge in India designed for contact blast load. The bridge will be able to withstand an earthquake of intensity 8 on the Richter scale. The location of the bridge exposes it to gale winds. The design takes this into account, and trains will be able to ply on it safely in winds up to 90 kilometers per hour. Beyond the safe limit, the sensors provided on the bridge will activate the signals automatically, which in turn stop trains from plying on the bridge. A bridge of this magnitude is only as strong as its foundations. Young Himalayan mountains provide serious technical challenges for the design and construction of foundations and slope stabilization measures. It was thus decided to carry out slope stabilization and then build piers that will stabilize the bridge and give it strength. The piers are no ordinary piers. The tallest is 137 meters tall. Such a tall structure requires massive foundations of 36.5 meters by 50 meters. The bridge crosses a very deep gorge with extremely steep sides. The slope varies from 43 degrees to an almost vertical 77 degrees. On such steep sides, slope stabilization is a Herculean task. As a first step, elaborate tests were conducted to understand the stability of the rock mass. Considering the demanding design of the bridge, the slope stabilization measures were designed by the Indian Institute of Science, Bangalore. The designs were proof-checked by renowned international consultancy firm URS. With the drawings ready, a very important milestone was achieved and preliminary activities started at the site. The activities include tree cutting, development of the dumping yard, dropping loose boulders and, most importantly, developing approach roads on the steep slope for plying heavy-duty dumpers and other construction equipment. On the Bakkal side, nearly 5 kilometers of roads have been formed on the slopes, and on the Kauri side, 3 kilometers. Catch trenches are created at each stage to prevent excavated debris from falling into the river. The total depth of excavation is 218 meters on the Bakkal side and 206 meters on the Kauri side. The steep slopes make the work extremely risky. The top-down method of construction has to be adopted from the safety point of view. The first step of the process is to cut and level the topmost bench. Once this is done, the excavation commences in steps of 3 to 5 meters. In each step, excavation up to a distance of 6 meters from the face of the final profile is carried out by normal blasting. Subsequently, and based on survey, pre-splitting is done about half a meter from the face of the final profile. It involves placing in a series of deep holes a small explosive to separate the bench from the part that needs to be excavated. Pre-splitting is essential to give a correct slope to the excavation. It prevents the damage of the rock mass to be retained from the vibrations caused by blasting. Controlled blasting is carried out to aid in excavation. After blasting, the heavy machinery like excavators, jackhammers, dumpers, track-mounted rock drilling equipment and dozers move into the area. The excavated material is dropped off in pre-designated and approved dumping areas. Immediately after excavation, rock bolts of designed lengths of 4 meters, 8.5 meters and 11.5 meters are installed. The rock bolts stabilize the slopes. Weep holes are provided beneath the shotcrete layer to prevent building up hydrostatic pressures, if any, in the future. Shotcrete with steel fiber reinforcement is then applied to the surface to strengthen and stabilize the slope. On the Bakkal side, more than 40% of the slope stabilization work is complete. Activities in slope stabilization follow a predetermined sequence. Delay in one activity can have a cascading effect on subsequent activities. And while one activity is taking place, the equipment for the subsequent activities perforce stands idle. It is a slow and meticulous process, and there are no shortcuts. Construction equipment consumes a huge quantity of diesel, typically 15,000 to 18,000 litres per week on the Bakkal side. The logistics for the arrangement of diesel from Riyasi, 26 kilometers from Bakkal and 40 kilometers from Kauri, is itself a critical process. Magazines of explosives for rock blasting also need to be stored and transported securely. The US BRL project is no ordinary project, and the Chenab Bridge no ordinary bridge. Its very demanding design requires special construction. Afghans is proud and fully committed to give the country the world's tallest arch railway bridge.